15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, ignition, and liftoff of the Atlas V with Maven, looking for clues about the evolution of Mars through its atmosphere.
Everything looking good, still at 100% rated thrust on the RD-180. Vehicle rates are looking good. We do have roll
And good afternoon, everyone. Welcome to the post-launch news conference for the Maven mission. Here to discuss how the launch has gone and the state of health of the Maven spacecraft, we have David Mitchell, the NASA Maven project manager from the Goddard Space Flight Center. Bruce Jakosky, the Maven principal investigator from the Laboratory for Atmospheric and Space Physics at the University of Colorado at Boulder. And Dr. Jim Green, the director of the Planetary Science Division at NASA headquarters. And we'll begin first with David Mitchell.
Well, good afternoon, folks. What a Monday at the office. You know, you build something to go to Mars, and we're now flying at Mars today. So it's, maybe I'm not showing it, but I'm euphoric. I mean, it's been great, guys. So you know, what an effort by this team to get to this point. And so many years ago, we started, actually, Bruce, 10 years ago, started down this path. And 5 years ago, we put in the final proposal, and we put November 18th, 2013 as our planned launch date, and we hit it. So, and it's, so far, I'll talk about the systems in a minute, but so far, so good. So I'm really excited about that. So today, the countdown went really smooth. You know, it was actually very quiet, which is the kind of countdowns I love. So all went well on that front. And we did hit the opening of the window right at, I'm gonna go into UTC time. So liftoff was right at 1828. So that all went well. After we lifted off, from a spacecraft standpoint, we had a test control center down here at the Kennedy Space Center, staffed by our engineers, and they did all the countdown portion of it. And then after liftoff, from a spacecraft standpoint, it was handed over to the operations center in Denver. The Lockheed Martin organization out there is now flying this mission to Mars. So, so we've got teams here. We got them over there in Denver, and so far so good. So I'm going to read from a script, which is simply the timeline of what happened and where we are. So, again, liftoff was at 1828. We separated from the Centaur at 1920. And 44 seconds, locked up on the telemetry at 1921 and 40 seconds. We confirmed system initialization, and tip-off rates were damped prior to initiating the solar array deployment. So that prop initialization was confirmed at 1926, and then we went ahead and deployed the solar arrays, and there was confirmed good collection. Good data confirmation of solar array deploy at 1955. From there, everything looks good. The signals are coming in fine, and so far, systems that are on are reporting back great. So we're currently, as of about 5 minutes ago, about 14,000 miles away from Earth, and we're heading out to the red planet right now, and we'll be journeying for the next 10 months or so. So far, so good. Our next major event will be a trajectory correction maneuver scheduled for December 3rd, and then shortly after that, in the first week or two of December, we'll start turning on all our science instruments, the 8 instruments. So I won't get into any more detail because we're still going through a scrub of the data, but all the reports are that everything is nominal at this point, and we were able to send up our first command. So far, so good on that front. But again, what a day. Bruce is going to talk more about the spacecraft teaming, but from a ULA and KSC LSP and the U.S. Air Force supporting us to get us this safe ride and drop us off just over 52 minutes after launch. You know, again, after a 10-year ride, and then to get to that point, thank the team, thank you all for getting us to this point. And Bruce and I have been saying this for years. We'll never claim success until we're at Mars, getting the data, getting the science data. So this really is just the beginning of the journey to get to Mars now. But just so happy about it, and I just want to say safe travels, Maven, and we're with you all the way. So thank you all.
Thank you, David. And now to Bruce Tchaikovsky, the Maven Principal Investigator from the Laboratory for Atmospheric and Space Physics at the University of Colorado at Boulder. Bruce?
Thanks, George. As Dave said, after 10 years of doing this, I don't have the words to describe what I'm feeling. It's every possible emotion, but they're all positive. This is about the most exciting thing I can imagine happening, and this day has been picture perfect from beginning to end. I do want to talk about the team because it's the people who got us here. The spacecraft science side of the house includes 5 major institutions: the University of Colorado at Boulder, NASA's Goddard Space Flight Center, the University of California at Berkeley, Lockheed Martin, who provided the spacecraft and the ops, and NASA's Jet Propulsion Lab. And I have to say it's been an incredible delight working with each and every person from those institutions. I think that we've managed to work together as a team in a way that I never would have imagined possible, especially from some of the stories you hear told around the water cooler. This has been a wonderful experience. I take tremendous pride in the team for what they've been able to do to bring the instruments, the science, the spacecraft together and give us a spacecraft that's on its way to Mars. In addition to the pride in the team, I also want to take this opportunity to thank our families and our friends, because they put up with us for the last 10 years, not showing up at family events, having Maven be the first priority much of the time for a lot of people. The team members are absolutely committed to making this work, and it's just incredible to see that level of commitment and devotion. And on behalf of them, we really appreciate what the families have let us do in going ahead and doing this. As Dave said, this is a really big milestone in the process. It's really easy to get caught up in the events surrounding a launch and to think this is it. This is the most important part of it. But it's a milestone along the way. We didn't propose to launch a spacecraft to Mars. We proposed to do science when we got to Mars. We have a 10-month cruise. Then we have another major event with orbit insertion. We have to, at that point, commission the spacecraft, check it out, and only then can we start doing the science mission. Every step along the way has been incredibly exciting, and it's going to stay that way. I can tell that already. And the last thing, hey guys, we're going to Mars. Thank you, George.
Thanks, Bruce. Now, Dr. Jim Green, our Director of Planetary Sciences at headquarters. Jim?
Well, of course, this is one of those days that you just can't stop smiling. And in true NASA tradition, the true understatement and the word that I love to hear is that everything is nominal. And it is, as Dave mentioned. That is so exciting for us to take that step. And as Bruce mentioned, it is an enormous team effort. But I want to mention a little bit from a headquarters perspective of how well this group worked. Indeed, they had tough proposal competition when Maven was selected to move forward in our Mars Scout competition. The team was spectacular, obviously, as Bruce mentioned, because of the way they responded and really stepped up to the challenges. And the challenge, of course, is our planetary windows. They're a blessing because I know they have to meet that, but they're also a curse. There is an enormous number of decisions that you don't see that have to be made along the way to be able to make that launch window. And this team did that. and the mission is all the better for it. In addition to that, another thing that from a NASA headquarters perspective I'm incredibly delighted about is that they did it under budget. And so that really bodes well for the science. The team is going to have an exciting venture as they go to Mars and really be able to make some critical observations, things that we've lacked in our understanding of the red planet. And that's a step along the way of further exploration. As Mars is our ultimate destination for humans, we need to know everything about Mars that we can before humans go to Mars, whether they're circling Mars in the tenuous atmosphere at the high altitudes that Maven will also transition as it goes then plunging into the atmosphere and through the ionosphere and back out in the solar wind, and understand what that environment's like, but also eventually down on the ground. And understand what's happened to this planet in terms of the climate changes, its history, and how it interacts with the solar wind and the light from the sun. So it's a tremendous mission. It's an important step along the way, not only for science, but indeed for our long-term destination as boots on the ground for Mars in hopefully our lifetime, my lifetime. So, George?
All right. Thank you, Jim. And we're ready now to take questions. What we'll do is take questions here first, then we'll go to the phones if we have any on the phones, and then social media are also invited to ask questions by going to #AskNASA. So we'll begin first here in the front with Peter.
Good afternoon and congratulations. Peter King with CBS News Radio, and you're talking about everything being nominal now. So moving this forward, what are the next important steps in terms of finding out that everything on board is doing what it's supposed to do? And I know it's a long shakedown cruise, so maybe in the coming days, weeks.
Right. So again, we'll be turning on instruments in early December. So that's an important point. There's some aspects that we won't know until we get to Mars. That is the deployments. So there's a lot of deployments that occur after we get into Mars orbit insertion. So that'll take some time, but certainly we'll have turned things on and made sure everything is nominal, or find out the condition. So it's going to be a while, but in the weeks to come, we'll be turning on all systems and checking them all out, short of deployments.
Is this one of those things that you do one by one, or do you turn on a whole bunch of things?
Yeah, we have 10 months, and we want to proceed methodically. And if there's anything that pops up, you want to take them one at a time and not be working multiple issues. So we've got a planned approach every step of the way as we get to Mars.
All right, Daryl.
Daryl with Fox in Orlando. How close was the weather call on this one? We heard that there was kind of in and out in terms of the green light. How close together clouds were kind of approaching too?
Yeah, I mentioned it was a quiet countdown, but that made it a little more interesting. So it was we were getting hits along the way, not lightning strikes or anything like that, but the measurement systems at the base were getting certain charge levels that would be ripe for a condition that we wouldn't want to launch. So they would get a hit per se, and then they would say we're red for the next 10-15 minutes, and then we'd come out of that and we're green. So it happened a couple of times. So yeah, that kept me a little bit on my pins and needles a little bit, because I sure hoped as we got really close to the liftoff that we didn't get a hit, and it worked out. It worked out fine. But that was, if anything, that was the excitement today for me as far as going through the countdown.
Marcia?
Associated Press with two quick questions. First for Dr. Joukowsky. Were you outside watching this launch, or were you inside? I saw you being interviewed so close to liftoff. And talk a little bit about your feelings, like when you saw the rocket finally fly with your Maven.
I was in the control room rather than outside. I thought it was more important to be at the console and sitting next to Dave and next to our observatory manager than to see it with photons going straight into my own eyeballs. I will tell you that in the last, I started to get nervous. Actually, I started to get nervous when I came back from the interview with George. That's in the, he has a little booth in the control room about 20 feet from where I was sitting. And when I came back from that and looked at the clock, it was about 45 minutes. And I was getting a little bit, well, the word anxiety comes to mind. I think in the last 10 seconds before launch, 10 or 15 seconds, I was shaking. You know, I can describe the physical symptoms. The words on the emotions just aren't there because it was all across the board. I've been incredibly nervous for the last 10 years. I know that we do lose spacecraft on launch. Not every launch goes smoothly. And in fact, that's the single biggest potential opportunity to lose the mission. So getting past this hurdle is a really big one. Now we get to the next hurdle where we have potential to lose the mission, which will be Mars orbit insertion.
And another question for you. I know that the ultraviolet spectrograph is going to want to take a look at the comet ISON. Is there any possibility of that going on early before the other instruments to see the comet before it goes near the sun, or no? Do you have to wait?
We have put plans in place to observe the comet from the IUVS instrument. Those depended on getting off early in our launch period, which we've now done. The next major steps will be checking out the spacecraft and doing the first trajectory change maneuver, which I think is December 3rd now, nominally December 3rd. And then we'll begin to turn on the instrument packages, and we've got a block of time set aside if everything goes smoothly to observe the comet.
So if it's still there after it goes around the sun? Thanksgiving Day is when it's going close to the sun. So.
Well, okay, Jim tells me closest approach is Thanksgiving. We're looking at, I think, the second week of December, more or less. If things go smoothly. It's not a commitment. It depends on how things go over the next 2 to 3 weeks.
Okay, additional questions over here? Let's go back in the back here.
Hi there, Amy Green of WMFE in Orlando. I was wondering if the Maven's mission is to help us understand atmospheric and climate changes on Mars. How will this mission help us understand climate change on Earth?
The processes, the physics is the same. How energy from the sun interacts with the atmosphere, what it does, the chemical processes, the physical processes, but it's different boundary conditions. So by looking at Mars, we do understand the processes better, and we can apply it back to Earth. But the real goal is to understand Mars. If we get benefit back at the Earth, all the better.
James?
James Dean, Florida Today. Dr. Chakosky, perhaps just following up your comment a moment ago. A couple of years ago, the buzz phrase around MSL was 7 minutes of terror. Everyone remembers. We don't have that dramatic landing sequence this time, but I'm sure you don't take orbit insertion for granted. Could you just, any of you discuss how difficult that is? Is there a minute or two of terror or something that you'll kind of try to focus people's attention on at that time?
Well, I think for me, it's 10 years of terror. There is no point at which you know it's occurred safely until it's occurred safely. And we're going to be spending a lot of time between now and orbit insertion making sure that we're ready for it, that everything is on track.
Ken?
Hi, Ken Kramer for Universe Today and Rocket STEM. I had a similar question about the orbit insertion. If there's anything you can add about what you're going to do to prepare and just describe that orbit insertion, then I got a follow-up.
Right. So getting back to Bruce's comment a minute ago there, one thing I've got to say is the team that's comprises Maven has done this before, and we have rehearsed with this group that's done it before. So for me, there's a measure of I can sleep at night. I worry, but I feel confident in the rigor of testing that's been done. But some of the testing early on will be demonstrating with some of the same engines we'll use for MOI, we'll be using for the trajectory correction maneuvers. So we'll be able to check those systems out. And then as we're flying to Mars, we have not only the Lockheed Martin ops group, we have the Goddard Mission Design Group, we have the JPL nav team, and they're all checking each other's numbers, so to speak. So you get a good beat on Mars, and you're headed in the right direction. And then getting close in, then you'll do your MOI burn, your Mars orbit insertion burn a few days out. So there's opportunities certainly to correct and deal with the situation. But I think with all the checking as we go along, both with hardware, with testing we've done already, and then the double checking that the people are doing now as we fly to Mars, we should be in a good position here.
Thanks. That's what I wanted to know about the double checking. And for Bruce, now this is your first time as PI, if I remember right, before you were a team member. I wonder if you could describe a little bit the huge difference in your responsibilities between being a team member, being a PI, and would you like to be a PI again?
I really recommend the experience. It's just incredible. The ability to shape the mission the way I think it should be put together in terms of the science, the instruments, the team. That's an incredible opportunity, but it's also an incredible responsibility to make sure that everything fits together. The biggest role I've played in the last few years has been to sit in on every single meeting I could to make sure that nobody did anything that would inadvertently affect the science in a negative way, to make sure that we're on track and we stay on track. It's been the experience of a lifetime, and there's no way I'll do it again.
This is Frank Mooring with Aviation Week. Just to follow up on that a little bit, Bruce, Jim Green said that you came in under budget. I wonder if you could tell us how you did that, if you have any lessons learned or guidance for future PIs into how to bring in a science mission that way.
I've got a 4-page list that I've been compiling of what I think we did right. And the hard part is knowing which one of those really were the things that let us come in with full functionality, on schedule, on budget, and which ones were the things that I just think were important. It's really hard to know what actually was important, but let me call out a few things. The first is putting together a focused science mission and minimizing science creep and engineering creep, the potential to make it bigger because, we can just add this, we can just add this. Let's make this a little bit better. We stuck with the mission we proposed. The second is we went with teams that are very experienced at doing this. Lockheed Martin on the spacecraft side has a tremendous heritage. They have flown spacecraft at Mars in missions, phases of missions that look a lot like what Maven will be doing. The science teams, the instrument teams have all built instruments, some of which are in fact identical to what we're flying on Maven, some of which are very strongly based on close instruments. The nav team at JPL, everybody's been through this and everybody works really well together. These things help an awful lot.
Okay, further questions over here? Yes, we have one right here.
Jeff Faust, Space Review. For Jim Green, you mentioned they came in under budget. Can you give us about how much they came in under budget, and does the project get to keep use that money for science or other work?
Well, it's my projection that they'll be under. We haven't paid all the bills. The window had a contingency for which we had budgeted the entire window. We used the earlier part of the window. So in the long run, we do anticipate that they'll be under budget. They certainly will not exceed their $671 million cap. And for that, we're grateful for. What will happen next, of course, is how that funding, if there is any that's left, will be used within the program itself. It's part of the Mars program. There's opportunities to enhance the science by, as the data comes into the archive, ensure that other scientists also join and have opportunities to analyze that data. So there's just a variety of things for which the money will go to good use.
Scott Holmes, newsplusnotes.com. How important is it to NASA's funding to go to a place as exciting as Mars, as opposed to looking at maybe a comet coming by, because of the culture change and the imagination of people?
Well, from my perspective, you know, we provide a variety of opportunities for our instrumenters to propose, our principal investigators. And of course, when we developed our last call, we had no idea that comet ISON coming from the Oort cloud, you know, traveling a million years to get here, was on its way. So what we're doing, of course, is we're leveraging the assets that we have. So ISON is probably the most examined comet from a NASA perspective than we have ever done. And the reason for that is we've used our assets at Mars to look at it. It says it's past the Earth, and even before then, we've used our telescopes at Earth. We'll be, you know, like Hubble and Chandra and Spitzer, all taking observations at wavelengths you can't get from the ground. And then, of course, now as it's going closer and closer to the sun, it'll be passing by Mercury, and we have Messenger there. Messenger will take observations of it. Comets evolve from the time they start brightening until they go all the way around the sun and go back out. And by having and leveraging these assets, it really gives us that view, that unique view that we couldn't get otherwise. Because of that, we couldn't possibly put together a comet mission, this one in particular, this Oort cloud comet, because we just didn't have enough time to do that. But it is important for us to study it in many different ways, and as Bruce mentioned, hopefully that they'll have an opportunity to take a look at it, and it will make unique measurements and perhaps aid them in their calibration even as they make those measurements and put them also in the archive for all the other scientists to analyze.
I also would like to do a quick go back, if I may, to Frank's question, because in running through my list of institutions, I left off a really important one that contributed in a significant way to the success, and that's Goddard Space Flight Center. We had incredible support from them, top to bottom, from the center director down through all the individuals. We had outstanding people working in the project office. And again, it was just a delight working with them, and that's a significant part of how we came in where we did.
Let's take a question right here.
Jason Ryan with spaceflightinsider.com. As David mentioned earlier, it's been a long road. It's been 10 years. You had NASA's Mars Scout program, which had 17 other missions that were proposed, and then, of course, Phoenix was another one that was selected under that. And so you got selected under that, and then we had the government shutdown. So I guess this either goes to David or Bruce. You know, when you saw the Atlas thundering off into the heavens, you heard the car alarms going off all around, you knew that you were on your way. What did it feel like to have all that stuff you had to put up with over the past 10 years off your shoulders in a way? Or was it just one stress went to another stress? What was it like?
You try.
Well, the government shutdown, I mean, that was just one thing, along the whole stretch. There was many stressing points, I'll say. But it really was, that's just the latest example of the resiliency of this team to overcome these kind of challenges. It's been incredible. So we were fortunately only shut down for 2.5 days or so, and we were brought back. And so people just responded, and you know, we added shifts. It was kind of funny because you'd come to work, whether it was at Kennedy or at Goddard, and a lot of the rest of the centers were still shuttered in terms of the staffing. So you were completely focused on Maven and getting it to the launch pad. You know, there wasn't a lot of other, you know, meetings to go to or anything like that. So it was, but it really did show the resiliency of this team. And, next, here's the next challenge. Okay, how are we going to do it? How are we going to deal with it and work through it? So to your question about, the feeling at launch, I guess personally, it's more, I'm locked in on what, I was really locked in on the countdown and making sure, everything I did that I was responsible for, I did execute the right way. And then I'm thinking about, okay, what's the next steps and what if there's a contingency or anything like that after separation? And so far it's been clean, but I do have a lot of comfort in the team and the system that's been tested, wrung out like you can't believe, and the team that's flying the spacecraft that, I felt good about that. So I was okay. And, I'm speaking from a spacecraft standpoint, but the track record of the Atlas V gave me some confidence too. So I was real happy that they had another string in their line of successes.
And let me add something on top of that when you sit and you rattle off all the different things we've faced over the last 10 years, it sounds incredibly daunting. But one of the hallmarks of this team, really of any team that gets here, is you have to do them one at a time. You can't look ahead to the next challenge and forget the one you're working on, but at the same time, you can't focus so much on this one that you forget the next one. But we faced it one milestone at a time, one problem at a time, and the team has been focused on each one all along. That really helped.
Okay, let's take some social media questions now on the hashtag Ask NASA. So.
Yes, this question comes from Michaela Horga. Will Maven be able to teach us about the effects of solar winds on our own atmosphere over time?
I think we're seeing the same physical processes at the Earth that operate at Mars. And the escape that is happening at Mars, some of that does happen at Earth, and we'll be able to understand it. So I'm hoping there will be some crossover, but our first priority is really understanding Mars, and we'll let some of the people on our team who cross over between the planets try to apply it to the Earth. I'm a Martian.
Next question also comes from Twitter. It's The Lone Wanderer. What kind of visualization of Mars' ionosphere will we get through the data Maven gathers?
We have a significant effort going on in data visualization because, as you might imagine, when you're dealing with this type of data, it's not images that come straight out of a camera. So it's very hard to represent in a way that even the science team can understand. And we require bringing all the data from all the instruments together really to get at our science results. So visualization is an important part of it. What I will say is that very early on, we'll be using the imaging ultraviolet spectrograph, which has the word imaging in its title, to provide images of the planet. There'll be images of the composition of the atmosphere. So it's very different from how you would interpret images of the geology of the surface. But we hope to make that as exciting to everyone else as it is to us.
Next one comes from Tyler Waldrop. Do you expect any further course corrections while en route to Mars orbit? If so, can you please elaborate?
Sure. We will definitely do, well, as a minimum, we'll do 4. So it's a matter of we're not aiming directly at Mars for planetary protection purposes, particularly with the Centaur stage. And so we're slightly off of that. So we'll do, for the spacecraft, not the Centaur, we'll do an initial trajectory correction maneuver in early December. And then we'll keep, we'll look at that data as we're flying. And the very last one, non-contingency type 1, is in September, the 4th one. So as we are flying there, as I mentioned, the folks in Lockheed Martin Denver, the folks at Goddard Mission Design, and the folks at the NAV Center at JPL are checking the data and seeing, how much more does the next correction need to, what do we need to do with the next correction? So there'll be a series. We're very methodical, careful, and do it over time.
We got another one from the physics story. How will Maven enhance capabilities of future rovers on Mars?
Well, Maven, of course, is going to make some fabulous measurements at the top of the atmosphere. And when you look at what happens with Curiosity sitting on the surface, it's making measurements of the atmosphere at the bottom. And so the correlation will be spectacular, I believe. It'll talk about the mixing and the composition. And so there's a rich set of information scientifically that I know will be pursued. And in fact, some of the same members are on both teams, and it will, which will naturally lend itself well to make those correlations.
We got two more questions. Another one comes from Doug Foster. How much power do the Gull Wing solar panels produce?
Let's see. I want to say what is it? 1,200. Yeah, I was going to say 1,000. It's about 1,200 watts.
And our final question comes from Doug Poole. Did the crew of the ISS watch the launch? Could they see it? Was it recorded? And that's it.
So I heard something about that in the countdown, or I heard something about it, but I don't know if anybody else on
I don't know the answer to that.
Yeah.
Yeah.
I heard they wished us well, but I don't know if what they saw.
And they did get out of the way.
Yes.
All right, we'll come back here for any last questions before we close out. All right, we have a question in the back.
Hey there, afternoon guys, congratulations. Andy Lichtenstein at the Avion newspaper at Embry-Riddle. My question can be addressed to any of you three. A lot of people, I don't want to speak for anybody in particular, of course, but many people in my generation are very excited about space travel, obviously. However, there's an equal number that simply don't know what's out there and what you guys are up to. So what's your message to the general public, and why is this important to the general public?
In terms of what we're doing to get the word out, we're trying to have a vigorous program of outreach to the public. We've done the usual things of having a very vigorous Facebook and Twitter presence. We hope that we're getting the word out and that people are hearing about it. For example, we had over 100,000 people submit their names to go on a DVD that is on the spacecraft en route to Mars. We had 15,000 people submit entries to our haiku contest on A Message to Mars. And the winners of that contest are on the same DVD, not the winners, the haikus, are on the DVD headed to Mars. We're trying to get the word out as much as possible. In terms of a message to people, we think this is exciting. We think it's a valuable enterprise for NASA, for the country, and for society as a whole. And we hope people are excited by it. And if we're not able to get the word out, please tell us how we can do better.
Any further questions? All right, in that event, that will conclude this briefing and conclude our launch coverage for Maven. Thank you.
Thank you.
All right, thank you.
Yeah, pleasure working with you.
It's been fun.